All right, ladies and gentlemen, welcome. This is chapter 2.5, where we are going to model direct variation. Direct variation is a form of linear equation. So by the end of this, we're going to be able to write and graph a direct variation equation, and we will be able to solve a direct variation problem in context. So let's go ahead and move on and talk about what direct variation is. Put simply, the equation y equals ax, this right here, is, or mx if you want to think of it as the y equals mx plus b that we've been looking at. This equation represents direct variation between x and y. Essentially, direct variation is a relationship between the variables x and y, where as x increases or decreases, the y variable increases or decreases at a constant rate of change. So put simply, you can think about slope without the y-intercept. So the big idea of direct variation is that you have this a value right here, which we would know as slope. We're going to call it the constant of variation. And all it really does is it explains the rate of change. Where, so if we have like y equals 3 times x, what this is really saying in terms of direct variation, since there's no like plus or minus anything else happening here, we're saying that as the x increases, right, as x increases by 1, the y increases I'm having a problem with that word, by 3, right? So every time the x increases by 1, the y increases by 3. If we were to change this to like -3, this would mean that as the x increases by 1, the y decreases by 3. Okay? And it's a constant rate of change. Like, that's the key. So direct variation is really very, very similar to what we've already been doing with this slope-intercept form and how we're talking about rate of change. It's just it doesn't include the b. It doesn't include a starting point. The starting point is always 0. Okay? So that being said, let's take a look at the following question. So we were going to write and graph a direct variation equation that has -4, 8 as a solution. So recall what we just said, that direct variation is this equation, y equals a times x. We need to find a. We need to find what that rate of change is. And once we figured out that rate of change, all we do is we plug it in for a, and that's our equation. Let's think about this equation for a second. So if I were to graph it, what I know about direct variation is that it's only talking about slope. It's only talking about the rate of change. The y-intercept, the starting point, is always 0. So it told me that I had one point at -4, 8, and that's good. That's this point right up here, 1, 2, 3, 4, 5, 6, 7, 8, right here. But I know another point that this line goes through. Because it's direct variation, I know that it goes through the origin, 0, 0. Because again, direct variation is all about the rate of change, and the starting point is always 0. So I've got my equation right there, or excuse me, my graph right there, because I have 2 points. So I know that it goes through like that, right? But what's the equation? Well, I need to find the slope of this line. And the way that we do that is by plugging in that point. Notice that we were given a point, x and y. X is -4, y is 8. if I were to simply replace those two values in the equation, right, the x value for the x, the y value for the y, and then solve for a, I would get a equal to -2. Therefore, the graph is right here. It goes through 0, 0. It goes through that point. My equation is y equals -2x. So there's my graph, and there's my equation. Again, all I had to do was find the rate of change. I did that by taking this x value, plugging it in, taking the y value, plugging it in. And that's it. I got a couple practice for you back on your Canvas, so if you can go try those on your own right now, then we'll come back and solve them in the next video.